All right, everybody, we're going to set up the chromatography column for experiment 27. We have to purify our reaction mixture. The reaction was done already, and we'll be purifying that reaction mixture. Right now, I need to put a piece of cotton here that will stop stuff from clogging the hole inside this burette. We shouldn't call it a burette today. It should be called a column for chromatography. And I'm going to put this piece of cotton in there gently. Just get it down there. And then I'm going to put a layer of sand. I only need about 1 centimeter of sand each time I use sand. That seems to be about 1 centimeter right there. And then I'm going to load this thing up with the powder. Now when you did TLC, the powder was silica gel. Often we use silica gel powder in this column. But today we're not. We're using a variation on it called alumina. But it's also a very polar powder. And it's an aluminum oxide. Not that different from the stuff on sandpaper. The gritty stuff, it's been put to a much finer powder here. So I'm going to load it up to about 16 on here. Maybe 15. There we go. And then I'm going to tap it down. And it goes closer to 16. And then put a protective layer of sand on it. Next up, I'm going to tell you what was done after the reaction was over to get your sample. So you stay focused here. I'll be right back. So what happened was, after the reaction was over and the solvent was evaporated, we got a big sample of crude product. In here is a mixture of acetylferrocene, diacetylferrocene, and unreacted ferrocene. Then approximately 300 milligrams of the powder was added to it. And then solvent was added to it to make what's called a slurry. It's like at 7-Eleven, you call it a slushy. And I just swirled it around. And then I went to the hood and I hit it with warm sand and air until all the liquid was gone. And here we go. It's a little lighter because it's got the white powder in there too. So this is a crude mixture of your reaction products and unreacted ferrocene that needs to be purified. I want to make sure it's finely divided so that it can go through my funnel. And it looks like it's pretty good. We'll work around it if it doesn't go through. And I want all of that in the column. And it seems to have fallen down fairly nicely. So up top we have our mixture that needs to be purified. It's getting trace amounts. And I want to make sure it's, well, I need that, level again. If I hit the side where it's up high, it tends to flatten out towards that side. Isn't that nice? And then sand. It's always been about 1 centimeter each time. A little less maybe, a little more maybe, doesn't matter. There we go. Sand is just a protective layer so things don't get disturbed. All right. Now what we have here is a dry column Often what you'll see done is a slurry is added directly to a column that's already wet. That's a wet column, slurry column. This is not that, this is the dry column. What I did ahead of time was labeled 5 Erlenmeyer flasks, and I weighed them. We're going to be putting liquid in here and letting it drip through into these flasks in order. Starting with flask 1. Oh, missed. And the first liquid today, in fact, let's look at the 3 liquids today. 20-to-1 hexane to dichloromethane. Then we're going to follow it with a slightly more polar 1-to-1 mixture of the same 2 chemicals, and then a slightly more polar 1-to-3 mixture of the same 2 chemicals. Don't get me wrong about polarity. Dichloromethane is just a tiny bit polar. Hexane is non-polar. So the mixtures are all non-polar, but if you put a little dichloromethane in there, it gets a little more polar, but it's not polar. It's not competing with things like water and methanol. Non-polar liquids. So I'm going to take the 20-to-1 and just get a sample for us to use. We're going to run it down the column. Now I don't want to disturb the layers if I don't have to, so I'm going to go slow at first. And as I get a more protective layer on top, I'm going to speed up. And you'll probably see already the ferrocene moving down. And once I get confident that I won't make too big a mess, pour. There we go. And the yellow is ferrocene. We saw a solution of ferrocene earlier before class started. Can you grab me that wooden block over there? And we do have samples of ferrocene. It's definitely yellow. And then the acetylferrocene is a little on the rusty side. And diacetyl's like a dark burgundy. It's nice. Chromatography is actually named after things that have colors, but most chemicals done purified using chromatography, we don't see it all. That's welcome to my world when I was in graduate school doing thousands of columns. Most days I did at least 2 or 3 of these columns. Some of these columns were very big because during the start of a synthesis, you have to make a very large amount of materials to do a multi-part synthesis. So I had a nice column that was about this wide instead of this wide. And it was about this tall. I don't even know if it's fitting on the video. Yeah. Okay? And for purifying multiple grams of material. We're purifying roughly 150 milligrams of material right now. And we don't have it dripping out yet, but I do see the ferrocene. It's already separated from the other 2. That's a mission accomplished. That's one of our goals, is to separate the 3 chemicals from each other. And visually you can tell that's happening with the ferrocene. We have to make sure we always have liquid in there. And if it starts going too slow, we're going to give it a bit of a power assist. Okay. So before we stop this early segment of the chromatography, I want to remind you ferrocene is the least polar chemical. It doesn't have any carbonyls attached to it. Any ionic separation of charges is balanced because there's an anion on the top and an anion on the bottom and a cation in the middle. So it's a non-polar chemical. No surprise to see it traveling nicely with the non-polar liquid, right? Acetylferrocene has a polar carbonyl group on it. It's up here in this band right here. Okay? It's still mixed with diacetylferrocene in the same dark band. Later on, when the materials have spent more time on the column, we will see a separation between these two species. We'll see a separation. And I believe that's a good spot to end this segment.